Okay, so last Friday we did arithmetic sequence and series, and today we're going to do geometric sequence and series. So we're on page 19 of your worksheet, of the 10-3 worksheet. A geometric sequence is a sequence in which each term after the first is the product of the previous term and a constant called the constant ratio. And it gives you an equation that you can use to find the nth term of a geometric sequence. A sub n equals a sub 1 times r to the n minus 1. A sub 1 is the first term. R is the common ratio that you multiply with to get the next number. And n is any positive integer. So it's like how many terms there are or which term you're talking about, what order it is. So on the first example, it says to find the next two terms of the geometric sequence. And it gives you 1200, 480, and 192. So to find the next two terms, I need to find the ratio that they're multiplying by to get each number. So what I'm going to do is I'm going to take the second term, divide by the first term, and that's going to give me the ratio. So when you divide, you should get 0.4. Now if you're looking on your notes on that first example, it shows you how to do this, but then the next thing it says, I'll show you on this sheet. It has 190 divided by 480. That's a typo. It should not be 190. It should be 192. There's no reason for that number to change. It's going to stay whatever it is in your sequence. Okay, so your ratio that you're multiplying by, or your rate, is 0.4. So that means to get my next number, my fourth number, I'm going to take 192 times 0.4, and you should get 76.8. So that's your next number in your sequence. Okay, to get the fifth number, you're going to take 76.8 times 0.4, and you should get 30.72. And that would be your fifth number. Okay, so let's look at number 1 in your assignment. This is on your page 19. It says find a sub n for each geometric sequence. And it gives you a sub 1 is negative 10, r is 4, and n is 2. So we are just going to use the equation that they give us at the top of the paper to find the a sub n. Okay, so I'm going to substitute values in. A sub 1 is negative 10, r is 4, n is 2. Okay, so following the order of operations, you want to take your base, raise it to the power before you multiply by that negative 10. You want to keep it in order. So I'm going to find my exponent. 2 minus 1 is going to be 1. So 4 to the first power is just going to be 4. So you're going to have a sub n equals negative 10 times 4, and that's going to be negative 40. So that's your a sub n value for number 1. Any questions? Okay, so let's look at number 3. Number 3 is a little bit different because they still want you to find a sub n, but they don't give you the a sub 1. They give you a sub 3. So you're going to have to find a sub 1. The way you do that is you're going to take your rate and divide it into the a sub 3. So if I divide the rate into a sub 3, that will give me the number before it. It'll give me a sub 2. It'll give me the second number. So I got 9 divided by negative 3. That's negative 3. That's my second number in the sequence. And to get the first number, which is what I really need, I'm going to take the second value, divide by the rate again, and your first number is 1. And so now you're ready to find a sub n. You'll have all your values you need to plug in. You don't need this a sub 3 anymore. So you're going to have to go back and finish that one, okay? Okay, let's look on the other page, page 20. We're going to find some partial sums. A geometric series is the sum of the terms of a geometric sequence. The sum of the first n terms of a series is denoted S sub n, and they give you two equations that you can use to solve for the partial sum. The first one, you need the first term, the rate, and how many terms there are. So you need a sub 1, r, and n. N is how many terms there are. The other partial sum equation, you need a sub 1, a sub n, which is the last term, and the rate that you're multiplying by to get each number. So two different equations. The one on the left, it has an exponent, it has that n as an exponent. The one on the right, you don't have any exponents that you have to mess with. So I kind of like using the second one better, but it's really up to you which one you like to use and what values they give you. You can decide. Okay, so let's look at the first example. It gives you a sigma notation, which means to find the sum. And it gives you the first k value, the last k value to use, and then the function. So this k is the value that they want you to plug into the function. It's not the same thing as the n right here. In your example, they have another typo, actually. If you look at it, I'll show you. Right here, that's the partial sum formula. That should be an n instead of a k. That first little exponent, that should be an n. All right, so I need to figure out, I'm going to use this second equation. The paper shows you how to use the first one. I'm going to use the second one. So I need to find a sub 1, a sub n, and whatever r is. R is going to be your number that's raised to a power. It's whatever number has the exponent. So for this one, r is going to be 3. So that one's easy to find. Okay, the a sub 1, I'm going to take my bottom number, plug it into the function, and get my value for a sub 1. So I'm going to substitute 2n for the k. So that means I'll have 5 times 3 to the 2 minus 1 power. And I want to take my base to the power first, and then multiply by 5. But this power is only going to be a 1, so it's actually going to be 3 times 5, which is 15. That's my a sub 1. A sub n is going to be a little bit bigger, because for a sub n, I'm going to take the top number and substitute it in for k. So that one is going to be 5 times 3 to the 7 minus 1 power. So I want to raise 3 to the 6th power and then multiply by 5. And I'm getting 3,645. Okay, so now I'm going to take my values and plug it into this second equation. The sum is going to be a sub 1 minus a sub n times the rate, which is 3, all over 1 minus 3, and that's going to be a negative 2. So we need to work our calculations. 15 minus, I'm going to put parentheses because I'm going to multiply the 3,645 times 3. And what I have right now is negative 10,920, and that's divided by negative 2. So my answer is 5,460. Okay, let me tell you one last thing, and we're going to do the next example. You guys need to listen. If I wanted to use the first equation, and so I needed to figure out what n is going to be, the way you solve for n is you take the top number, which in this case is 7, subtract the bottom number, which is 2, and then add 1 back. You always have to add 1 back, so you'll be counting that bottom number. So top minus bottom, and then add 1 back. So that would be, your in here would be 6. Okay, let's do one last example before you guys start on your assignment. This is example 2. Find a sub 1 in a geometric series for which S sub n is 1,530, n is 8, and r is 2. So they want me to find a sub 1. So for this one, I don't have a sub n, so I'm going to have to use that first equation in the box. Okay, my S sub n is 1,530. A sub 1 I'm going to solve for. R is 2, and n is to the 8th power. So that 8th power only applies to the 2. And that's all over 1 minus r, 1 minus 2, so that's going to give me a negative 1. So the first thing I want to do is take 2 to the 8th power. Do you guys know what 2 to the 8th power is?
256.
256. Okay, so a sub 1 minus 256 a sub 1 divided by negative 1. And I can simplify that numerator. I can combine my like terms because they both have an a sub 1. 1 a sub 1 minus 256 a sub 1s. Yes.
Why is it 150? Or why is it 1580?
Oh, I should have. I'm sorry. Thank you. 1530. Okay, so now I just combined my like terms here in the numerator, and I got negative 255 a sub 1. So when you have a negative divided by a negative, that's going to make that positive. And now you can find a sub 1 by dividing by the 255, and you should get 6. Good. And that's your a sub 1 value.